My dear students, now we are going to look at POS function implementation using decoder. POS stands for product of sums. We will take up a decoder, we will take up a function, then we will see how to implement using decoder. So we will take two cases of decoders and we'll try to see how to implement it. Okay, so there will be three inputs as usual. I am going to take a function of three input variables. There will be enable input, there will be 8 outputs, right? So 8 outputs, active high possible, right? Then active low cases. So 3 to 8 decoder, which are we are aware of. This is ABC. Okay. So this is Y0 to Y7. Let's take a function f of ABC is we want POS. POS is product of sums. Say I say 1 to once again 4 6. Now what is the meaning of this is for 1 to 4 6 it is 0. So can I look like this? I write ABC 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1, right? If that is the case, what exactly it is going to happen is the function f is 0. Let's write the serial numbers. Okay, 0 1 2 3 4 5 6 and 7. Now it is 0 for 1, it is 0 for 2, it is 0 for 4, it is 0 for 6. And what about the rest? Rest all ones. Okay. So this is what exactly we want to implement. Now what I try to do is I'll take the decoder. I'll take the decoder. For this decoder, what I try to do is I try to implement this POS function. So let's say the inputs are A, B, C. There is a active low enable which I am connected to ground. Once I connect it to ground, this is on. It works. Start work. Power will be on, of course. So now what I try to do is I'll take up the outputs. Okay, how many outputs? 8 outputs. Done. So this is your 3 line to 8 line decoder. From this, what exactly that I am trying to do is if I take active low, we will see. You will also see if I take active high. So this is your Y0. Of course, this is Y7. Now what I want is for 1 2 4 7. So this is 0 1 2 3 4 5 6 and 7. You take 1, you take 2, okay, you take 4, then you take 6. Okay, then what exactly this exactly that you are getting here is ABC. These are all actually min terms. Because of the bubble, they are max terms. So how the max terms will be? Product. So that means I need to do ANDing. If I do the ANDing, then my job is done. If I take a AND gate, then my function is received. Okay, done. Because there is a bubble, okay, active high input. Because of the bubble, it becomes max term. Every term is max term. So if you AND the max terms, then your result is ready. Now if if for a decoder outputs are active high, inputs also active high, in that case, if at all you refer to what we need to do, how exactly we supposed to solve the same problem. So if I take the outputs, there are 8 outputs, right? These are the 8 outputs. But this time I would like to have active high. So let's not have all these bubbles. Just remove the bubble. So what I try to do is just I'll connect this. So I have totally 8 outputs starting from y0 to y1. What I want to implement is max terms, but what I have is min terms. So I will take all these min terms, I will convert them into max terms because I want to implement max terms because it is a POS. 5, 6, 7. I take 1 and 2, 4 and 6. Okay. What I try to do is I will try to R them. You try to R them. If I R them, what I am going to get? I am going to get all the min terms, right? But I don't want min terms, I want max terms. So put a bubble here. Then you say function. So because of the bubble, what exactly? For ABC combinations, for these terms 1, 2, 4, 6, you will get output 0. For all other cases, output will be 1. Okay. This is how one can implement POS functions. POS function. What is POS function that we are looking for? POS is product of sums. So this POS function using decoder, as usual, we will look for number of inputs. Based on the number of inputs, we decide which decoder to use, and from that we can get it. So it may be active high outputs or active low outputs. Okay, in either of the case, one can solve the problem. Okay, so here I didn't write here, but you can write y1, y2, y3, y4, okay, y5, y6, and y7. Similarly, in the previous problem also, here y1, y2, y3, y4, y5, okay, y6, then y7. Okay, that's all. Done.